Lesson 9.3, identifying rational functions and graphing them. There's some information I want to get you today that's a little bit long-winded and heavy in the symbolism, and so we'll need to talk about, make sure we understand what's going on. So I'll pause now so you can copy this down and we'll talk about it. Yeah, it's a rational function, not ration function. Just to make sure you understand the symbolism, f of x, oops, put a marker on. F of x is a function, okay? In terms of x, p of x is another polynomial function in terms of x, and q of x is another polynomial function in terms of x. And so they're just expressions, okay? It could be something as simple as x over x plus 2. All right? It could be a lot more involved. It could be quadratics. It could be, third degree, fourth degree, whatever. All right? And then down here it's saying if a, little typo on what we had originally there, if a is a real number for which the denominator of a is a rational function, so a situation like this, f is a 0. And so what we're saying is, what's the value of a here that make this 0? Negative 2. So we're saying if a is negative 2 in this scenario, then the domain of f, then a is not in the domain of f. And so in other words, my domain for this, we'd say x cannot equal negative 2 because we can't allow the denominator to be 0. And then the graph of this function f is not continuous at x equal to a, and the function has a point of discontinuity. Okay, well we experimented with that in that little project we did. We found holes, right? And we found asymptotes. The two things that occur when we have points of discontinuity. And so in this lesson, we're going to try to teach you how to look at an equation and know whether it's going to have a hole or an asymptote and what those zeros are. Okay? Where they occur. That's what we're going to look at. The vertical asymptotes are found in these situations. So I'm going to pause and let you copy this down. So AJ's question is that these two are mutually exclusive, they can't both happen at once. So let's back up, make sure we understand what we're looking at. The rational function f of x is equal to p of x over q of x has a point of discontinuity for each real 0 of q of x. So that's what we were just talking about a moment ago. For each of these numbers that make a 0 in the denominator, there's going to be a point of discontinuity. The first one says, if p of x and q of x have no common zeros, then the graph of f of x has a vertical asymptote at each real 0 of q of x. And so what we're saying is, let's say on top I had x plus 2 and x minus 3, and on the bottom I had x plus 1. Okay, the 0 on top would be a negative 2 and a positive 3. Do you agree? The 0 on the bottom would be a negative 1, right? So that would be this scenario right here, where they have no common zeros. Then the graph will have a vertical asymptote at each of the real zeros of the bottom. And so that means that if I was to graph this at negative 1, that didn't work out so well. Let me do this, it'll be easier. At negative 1, we're going to have a vertical asymptote. Okay? So in the top and bottom have no common zeros. The bottom is going to have a vertical asymptote. All right? Now the next one. If p of x and q of x have a common real 0, a, then there is a hole in the graph or a vertical asymptote at x equals a. Okay? We have to look at that or a little bit closer. In my experience is when they have the same zero, it's just going to be a hole in the graph, okay? Now, your question was, are they mutually exclusive? No, it's possible. It's possible that I have x minus 3 down here, okay? Where these two right here are the same zero. So at x equals 3, there's going to be a hole in the graph. And this one here does not share a 0 with the numerator. And so that means at that point we're going to have a vertical asymptote. So you can have both at the same time. Okay? I typically look at it as if the top and bottom have the same 0, it's just going to be a hole in my graph. And if the bottom has other zeros, there's going to be asymptotes there. Okay? All right. We'll look at that. Let's turn the page. Copy down the horizontal asymptote rules. Can I cover up the title, horizontal asymptotes?
Yes, sir.
Then we can get it all on the screen. Again, this is just a period here ending this statement. A is the coefficient of the term of the highest degree in the numerator, and B is the coefficient of the highest degree term in the denominator.
Stay on.
So again, we have 3 scenarios here. Okay, 1, 2, and 3. If the graph, if the degree of the denominator is bigger, then the horizontal asymptote will be at the x-axis, y equals 0. If they're the same, then they'll be at the line y equals a over b, where a is the coefficient to the highest degree term in the numerator, b is the coefficient to the highest degree term in the denominator. Or the third one, if the numerator has a higher degree than the denominator, the top has a higher degree than the bottom, then there's no horizontal asymptote. And again, there's at most 1. So there's either 1 or there's none. Okay? 1 or none. So, if I just look at this, y equals 5x squared plus 2x minus 3 over 3x squared minus x plus 4. Okay? Just an example to look at. Tell me where the horizontal asymptote is at. If there is one. Maybe there's not. Okay, which scenario does this fit? 1, 2, or 3? 2, because they have the same degree, right? They're both second degree. So where is the horizontal asymptote at? Y equals a over b. What's a?
5.
And what's b?
3.
So there's the equation to the horizontal asymptote. Y equals 5/3. Okay? Now, if I have this scenario, where's this horizontal asymptote going to be? Okay, so we're starting to talk this out. You can't hear it on tape, I'm sure, but you're noticing they don't have the same degree, and the degree on the top is bigger than the degree on the bottom. So that is scenario number 3, which means there is no horizontal asymptote. So when I said, where is it? And the answer is there is none. So no horizontal. Asymptote. What's nice about this is it doesn't matter what the zero is. Doesn't matter where the zeros are. Doesn't matter if they're the same in the top or the bottom. The horizontal asymptote is either going to be at the x-axis, y equals 0, at y equals a over b, or it doesn't exist. Yeah.
So you only need to look at the coefficients to decide whether it has one or not. Or
Right.
The coefficients, the powers.
The degree first,
Yeah.
and then if they're the same, you look at the coefficients.
Oh, okay.
If they're not the same, it's either going to be at the the x-axis, or it's going to not exist. Okay? Oops, let's come back. Maybe come back. Excuse me. What if I have where's that horizontal asymptote going to be?
0.
Make it clear for everybody what you mean by 0.
Because you have 3 x's in the bottom one, so when you end up multiplying those out, it'll be x cubed, so it'll be...
Okay? So you're saying if I multiply this, I get something like x cubed in the bottom,
Yeah, and then x cubed in the top.
x what?
X cubed, or x squared,
X squared
plus something.
in the top, right? So in other words, my highest degree in the top is going to be 2, and my highest degree in the bottom is going to be 3. So now I'm still confused on what you meant by 0.
The horizontal asymptote will be at 0 since the denominator is greater.
What's the equation that represents that?
Is it...
Louder, please.
Oh,
Okay. Y equals 0. Alright? Always put it in equation form, and if possible, no, not if possible. Always put it in equation form, so it'll always be y equals. And it'll either be 0 or it'll be some fraction, right? That fraction could be 2 over 1. You know, it's possible my numerator's coefficient is 2 and the denominator's coefficient is 1. So you just get 2 over 1 or 2. Okay? Any questions on this? Yeah.
like, if we have a problem like that where it gives us the factors, do you want us to write out the equation? Or the...
No, you don't have to. I mean, I agree. Now, if they're the same degree, then we'd have to multiply these out to get what those numbers actually were, right? At least part of it. I mean, I think we could do it.
Wait, so like, if it doesn't give us, like if it's like that, but
Let's say I had
just like, yeah, another
x
term
minus
there.
7 here. So now they're the same.
It would be at 1 because there's no coefficient in front of the x.
Right, so it'd be 1 times 1 times 1 over 1 times 1 times 1. Now if I had a 3 here and a 2 there, and a 5 here and a 3 there, then my highest degree on top would be 3, and its coefficient would be 3 times 2 times 1, which is 6.
Yeah.
and on the bottom I get 1 times 5 times 3, which is 15. So my equation would be y equals 6 over 15, which reduces to what? 2 over 5.
And that's the horizontal asymptote.
That would be your horizontal asymptote, yep. What's that? Yeah. AJ?
So, this is probably obvious, but, so, let's say the numerator and the denominator in the answer for the horizontal asymptote, that's just, the number value on the y-axis that it is.
Yeah.
It's not like, like the numerator is x. and
Right, so if I went to graph this, one, two, three, 2/5 would be right around here, right? And so my horizontal asymptote would be this line.
Oh, and that's where you'd start your graph, right?
Yeah.
Yeah, okay.
Yeah, our graphs are gonna be a little different now, okay? There's a little more to graphing these, and
So the
I think it can be done by looking at the equation, but it's not bad just to find your holes in your asymptotes and then draw look at your calculator and then draw it from there, okay? But you still want to do like I said here, you want to identify your asymptotes. So make sure you identify where your asymptotes are. Make it clear when you draw your graph. And then if you look at your calculator from there, I'm okay with that. We did not talk about these at all. Okay, where they go, what they look like, how to find them. So let's do that real quick. Yeah, assuming we have time. We need to finish this first. If I had this scenario,
Wait, what was this for?
okay? If I have this scenario, it kind of goes into that OR statement I was talking about. Okay? These have the same hole at x plus 2, don't they?
But something.
And they have the same hole at x plus 3, don't they? Okay? But we have an additional 0 here, again at x plus 2. And so if we look at this, and we were doing the algebra of this, these would cancel, wouldn't they? Okay? And so I'd be stuck with, I would end up with y equals 1 over x plus 2. This one that's left over here. Okay? If I just graph that one right there, if I ignored the rest of this and I just graphed that, I would see at x equals -2,
So negative half.
at x equal to -2, I would have an asymptote, okay? Because x cannot equal that, and so that would be like up here. And like over here. Okay? That's how we graphed that last week, right? Go ahead, Max.
So like, if you have 1 over x plus 2, wouldn't that be negative 1/2? Or do
1
you-
over x plus 2.
Wait,
Yeah,
so-
because x equals negative half. I mean, x equals -2, but you have 1 over -2.
But it's negative 2 plus 2, which is 0.
Oh,
I'm saying if I put negative 2 in right here, negative 2 plus 2 is 0. And so it'd be 1 over 0,
oh, it's the, oh, okay.
right?
Yeah, I get that.
That's why at this point right here, the graph can't exist because I can't allow x to be negative 2. But if I go back to the original, x could not equal what?
3.
Could not equal 3 either, negative 3. So if I go to negative 3, at that point right there, there has to be a hole in our graph. Because we can't allow x to be negative 3 either.
And there wouldn't be a hole at 2 because.
No,
we're at
because,
negative
well,
3.
there's a big hole there, it's called an asymptote.
Yeah, because it won't ever touch it, yeah.
Yep. Okay, so in that one statement right here, or a vertical asymptote, this is what they're saying. They share the same 0, but the bottom also has that 0 again. And so because it has that 0 again, it's creating an asymptote there. If this here wasn't there, and we cover that up, and all that was left was the x plus 2 and the x plus 3 that were canceling, then we would have holes in those parts of the graph. Okay?
So would that just be at the origin, like the original y-axis?
Are you saying if this wasn't here at all,
Yeah.
and I had just this,
Yeah,
Right.
wouldn't it be, you wouldn't move it at all, you just have 0.
right, so everything would cancel, I'd be stuck with y equal to 1, right?
Yeah.
So when I went to graph that, I'll do it in green, I would get this line, right?
Yeah.
But at negative 2 and negative 3, I would have holes in my graph.
Yeah. So the y-axis will only move if there's like uneven number of terms on both. So like since you have 2 terms on the top and 3 terms on the bottom, but well, never mind.
Are you talking horizontal or vertical asymptotes?
It's a lot vertical, but
Okay.
I know what I'm talking about.
Yeah, that, it doesn't matter if even or odd, top or bottom. If the bottom creates a hole, it's either gonna be an asymptote, or it's gonna be a vertical asymptote, or it's gonna be a hole in the graph,
Okay.
okay? And if they share the same one, it creates a hole. If they don't share it, then it's an asymptote. And this extra one that we canceled out here, it's getting hard to see, this one wasn't canceled out of the problem, so that's why we have an asymptote there,
Yeah.
okay? Bethany?
Why is the asymptote not 2? Why is it negative 2 instead of
Because
2?
you have to change it to 1.
Well, because if I put a positive 2 in there, 2 plus 2 is 4.
Right.
1 over 4 doesn't create a problem. The problem is created when I put negative 2 in there. Negative 2 plus 2 is 0.
Right.
And then I'm dividing 1 by 0.
How come you have to put it over 1?
Because that's what this that's what happened. These 2 canceled and there wasn't anything left on top but a 1. I didn't put it there. That's just the way the problem was. I mean, if I had a 3 out here in front of all of them, then it'd be 3 times 1, which is 3.
Right.
I'm just saying after I canceled these like factors, the only thing left in the top was a 1. Okay? All right, any questions on that? All right, it's going to take some thinking time to get through this. I will put the answers up